So my name is Sabah Bushaj. I'm an assistant professor at State University of New York at Plattsburgh. My research is in mostly analytics and optimization. So basically building some bridges and some dashboards or even optimization models in between those, ranging from invasive species modeling up to reinforcement learning models for that purpose. So for today, what I've planned is on the first hour, I plan to go over Tableau. Just there's so much details to Tableau, so I'll try to condense that into a short 50-minute time. And during that, I'll show how we can create different sheets, how we can use some of those features, and then also how we can create a dashboard from that. So for those who might not be familiar with Tableau, so basically it's a visualization software, but more than that, there are others on the industry as well that are used. You might have heard of Power BIs, or in that case, I see similarities a lot. So if you actually are able to, let's say, work in one, you should be able to work on the other as well. Whenever you do that, it comes up to a matter of preference on what you like more. So I want to start with a blank worksheet in Tableau. And as I mentioned on the preparing materials, you can always get, especially if you basically have an EDU email, you should be able to get a 1-year free license from Tableau. They do provide that. And I want to start with an empty sheet and then start building on that. So the first thing that I want to stop at is basically the data set that we're going to use. So I've obtained the data set from New York City Open Data. So basically it's a property valuation assessment data. I try to basically get something that it generalizes to a different audience. A lot of the, let's say, methods that we'll use, a lot of stuff we'll do with this data, it's actually applied to any type of data. So just as long as they fit on the same, let's say, general idea on what you want to perform with the data. The data here was huge. So to just make it a lot more practical, I've just done some pre-processing on this data set, and I'm going to use the same columns, the same fields, but just a simpler, shorter version of that data. And so whenever we want to visualize, I use this practice a lot before even starting dealing with any of the data, because it paints a very beautiful picture. You can try to read some descriptive statistics from the data or so, but if you visualize it, if you map it, it can tell you a lot about its content, especially if that data is a huge data and it's not very practical to deal with, even sometimes if you want to go ahead and code. So when it comes to Tableau, we have multiple options that we can connect to data. We can use Excel files, JSON files, any type of basically databases that you might have the data at. In this case, I plan to use the CSV, so I'm just going to try and select this CSV. So basically, this is the same information that the NYC Open Data has posted there, but I've just reduced it so that it is easier to work with. Once you try to link some data, it will actually take you through this view. In this case, it's like a preview before you start working with the data. You want to make sure that you're reading the data correctly and that Tableau is recognizing some of those fields correctly. Now, if you open the CSV, actually, this is what we're going to see, right? We're going to see some borough information, neighborhood, building class category for each of the properties that are assessed there, tax class at present, and so on. So there are quite some fields that are associated there. Among fields that I want to mention are sale price, which we will deal some with it later on as well. And we will select some of these fields just so that we can focus and move towards a meaningful aim in terms of the 1 hour, 2-hour workshop. So the first thing that you notice actually when you do this is that you have some type of icons here. Those typically will tell us what type of data that's being covered on that column, whether it's numerical, whether it's string, or even in that case, if you have dates as well, in this case, it shows them as a date type. And even before you move on with this and continue visualizing, you can always try make changes here. You could create new fields, as we'll do later on. You could create bins of this of a certain category, groups, and so on. Depending on which field you're dealing with, you have different options. As for example, in strings, you can create aliases, so you can refer to these in a different, let's say, shortcut name or so. You can split the data as well. If you have a certain string and you want to split it, then you can do that even before you start working with it. An additional feature is also the data interpreter. Sometimes in this case, it will try to clean up your text or to clean up the information that's in there, which means if there's any issues, is going to try and correct those issues. Now, this is a simple test data set in the sense that it's one file, right? Here you also have an option that if you have multiple files that are extracted from a database or that have some sort of a joined information, shared keys, and so on, you can always create a relationship in this view as well. So it can actually serve as just as good as any relational database management system. So I mentioned I've shortened the test data. I've not shortened that much, right? As you can see, it's still processing on that. All right, and yeah, if there's any questions, please feel free, especially if something that's should be dealt with, feel free to jump in and ask. So now, in this case, what I'm going to do, as you see here, I've now connected the data. I have one connection here, and I can go ahead and move to a sheet. If I move to a sheet, this is the view I'll see. Now, this is all the data that I've imported. Whenever you start working with some data, as I mentioned, you want to do some checking first. You want to see whether the data that you got is actually meaningful there and whether it's actually, let's say, understood correctly from Tableau. As you see here, we have, in this case, we have two different types of data sorted here. We have some dimensions here. We call them as dimensions, and then we have here some measures. Typically, the difference between dimensions and measures is that Tableau will treat categorical data, which like names, strings, dates, geographical information, it will treat them as dimensions. And then everything numerical will actually be treated as a measure. Sometimes, as you can see here, for example, the year built, if we try and see here, this data it was actually put as a dimension, but if you try to see what information it holds, and so in this case, it says that, in fact, it's saved as a continuous dimension, but if you look at it, it's actually a year, right? So you can always say, all right, if this is not placed as to let's say per your idea of where that should be, you can say, in this case, you can convert it to measure and it's gonna be moved to the proper location. So basically, while it tries to do a lot of work for you, it is up to you where things should be and how they would make sense. Similarly, in this case, you see zip code, for example, this is geographical data. In that case, it's actually is placed as a dimension. Sale price as well, it can be moved. And there's basically quite some adjustment that you could do in any type of data set, just because while it helps, it's not going to do the job for us fully. And from here now, moving forward, so this is our side view. We have some analytics here. During this session, I will not go into too many details on that at all, but just want to point that while we can visualize, we can actually try to also make some projections. We can see ranges. We can also basically plot lines or even forecast with Tableau. The main view here, it's quite helpful. Basically, we have columns and rows. Right now, we're not doing anything. We're not using anything there. And we also have some sort of help here that we can use that anytime if you want to see what could we do with our data, right? And then we have some smaller windows here, which we will use them quite a lot. That helps us to shape our graphs or our visualizations. So for example, if we just go into that and saying that I want to visualize some information, as you see, as soon as I select some sort of dimension there, it highlights what I can do with that. You can, in this case, you can place it as a column, row. You will later do filters as well, and also different marks. In this case, if I place it here, what's going to tell us, it's just basically is going to show all the type of data. It's saying that this is a string here, and what the value for that is A3, and all this represents the class of the building currently for certain records. And if we want to map to that, we could say, we could always look at different measures that we want to show for that. If we, for example, in this case, if we want to look at the building class category, and then we can look at the gross square feet that they have. For each case, we could say that in this case, we have, in this case, gross square feet is shown as a dimension. We already know, even if you are not sure, if you have not checked the data set previously, you can always take a look at that and see the content and how it's described, even before making any moves of moving it into a measure. So I want to convert this into a measure, and I want to drag it here. Now, as soon as I do that, it's actually visualizing here based on what it's showing by the category, by the building class at the present time, and it's showing me the gross square feet in millions of square feet. Now, while this is, again, so it's just a simple representation of that, the flexibility that Tableau gives is very convenient, especially now. This doesn't look ordered. We don't, let's say, get a lot of information. You could do sorting based on the largest values to the smallest, and so on, right? So in this case, by default, we were able to build that. We did not name anything, so it just shows a sheet name. If you want to see what we're doing here, I can say, all right, let's name this sheet as, I can say, building class by gross square feet. And you'll see that automatically it will update it here. If you want to just visualize that better, you can double click on that and it will show. You see here that that's why it was updated, because it represents the sheet name. So you can choose any type of let's say text size, or just try to basically build that. And if this looks as a duplicate, you can just say hide this here, and you can basically visualize it in a more meaningful way. Now, if you're interested in showing just some of this information, if you're not interested at all of, let's say, at all of these categories, if you're interested at the largest ones here, you can always, we'll see that you can always filter and so on. And typically in this is just a typical graph basically, but you can always get other ideas on how this would look like without hurting your graph, right? So one feature that I very much enjoy is sometimes, now while this is a very simple plot, and I can definitely decide that, all right, the categorical value with some numerical value, this combination is very proper. I always find myself, whenever I'm dealing with more complicated or more dimensional data, that looking at different options that I have can actually produce interesting type of, let's say, visualizations. All right, so now I started small with this. Now, what we know so far, we know columns, we know how we can manage those. Of course, you have, these are some simple capabilities that are as shortcuts here, but you can find them also on the data as well, or worksheet. And you could basically turn things around or try to see what fits best on a certain situation. So I'm going to leave this sheet here, and I'm going to start now with a new sheet just to show more information on what we can actually do. So if you notice down at the menu, we have an option to create a new sheet, we have an option to create a dashboard, and we have an option to create a story. So for today, my plan is I'll create some sheets, and then I can put them together in a dashboard that then could easily be published in any, at any page, or basically where you want to showcase that. So I'll create another sheet here. Now, what I want to do here, I want to get this, I want to use this geographical data. So far, in terms of geographical data, I only have a zip code here. Boroughs can be as well, in this case, some geometrical data, but they cannot be mapped directly by that, as especially they are shown as a measure, which means in this case, probably the New York City, they are holding this data as a numerical value just to basically kind of map this to, let's say, one is Manhattan and so on. So what I can do here, I can say, let me drag this zip code here, and I'm going to put this zip code in a color here, and I want to do some mapping data here. Basically, if I show it this way, it's going to show me what that refers to, right? In this case, now I'm looking at all of these data so far. The one thing that I did
How did that happen? I missed it. Can you
yeah, so exactly. One thing that I did not have to do here, I did not have to add these fields. Every time that you import a certain data set that has geometrical information on Tableau, these two are going to be generated, which is latitude and longitude. So basically what I had to do only is I had to add here, in this case, the zip code. And as soon as I selected, in this case, this graph here, it helped me create that, right? So I just said zip code, and I added here because I want to do coloring on that. You could add that by size. We could do quite some. We will do some stuff with that, right? So if I add it here, it handpicked this option right away. So it doesn't make any sense to us. It's not compelling, right? Then you select a map because we know that this actually is going to fit on that map, right? If you want to see a coverage, then you can select another map there, right? So in each one of those here. Now, so far we're seeing here the New York City area and also the boroughs there. So what I can do here is, together with this information, I can combine this by color, and based on that, I can add more information. So for example, what if I want to show here these as circles, and based on a measure that I have, I want to see which one is bigger, which one is smaller, and I want to differentiate visually. So that way we use size in this case. So by that, for each one of these zip codes, a bigger size can mean that that measure is more in value. So for this case, I can say, depending on the zip codes, what I want to do is I want to see the total units on a zip code, right? And total units on a zip code, I'm going to drag that to size. That way, here it's going to show me the sum total of the zip codes. All right. Now, so far, we're okay. Still doesn't look that good. Still doesn't look that good. In this case, I'm going to do coloring as well based on the information there. One thing that it shows me here as well is that I could kind of handpick any of the zip codes that we have here. Now, for more information, what I can do here, I can go to background layers and I can deal with map here. And I have multiple stuff that I can include in this map. So one thing I can do here, I can say use a terrain view. So if I use a terrain view, this is actually going to basically change. Let me see here what I can add more. So I want to add. I want to select here a satellite. So we can just go over that as well. So I can use a satellite view. What I like mostly about this is typically I use a lighter version of that, which is, you know, it's easier to sometimes see. But what I'm going to go with today is just basically looking at streets. It's even, I can wash out this a little bit, meaning I can kind of, I don't want to have so much coloring on it. I want the dots to be more observed there. So that way I can move that. And then I can select what I want to include or what I don't want to include in this case on the map. I can say that highways, I want to leave them. I don't want to have, let's say, house numbers or no stations and whatever I want to, basically depending on what I want to show there. So all of this information is very helpful depending on the data you're dealing with. It can give you a lot of power to visualize basically. So I can relate that to the GIS workshop that we had, but this is just a visualization in terms of a quick to see our data in action. So far, so good with that. What we can do here more is, in this case, even on the map options here, I could basically use scales. I can decide whether or not to show one label. I can zoom in onto different areas of the map that I want to highlight. And more importantly, that something that can help me visualize this even better is sizing, right? So right now, those dots, I don't like the way how they are looking. So what I can do is, they are zip codes, they got to cover more area, and I can move them a little bit more in there. So that gives me a better view of actually which of these zip codes has more units, because we are looking at the sum total of the units that are on a zip code. And based on that, I can add more information again. I can add boroughs here. So basically, I can do here, I can add that as a label, and I can see which borough they belong to, right? So they might belong to, in this case, this is borough 5. If I select any of these, point at some, let me see, not a sum of boroughs. So this is a typical thing that can happen when you do not, for example, in this case, I did not treat this properly and it's showing me sum. Why? Because it thinks it's a measure. What I can do, or how I can quickly fix that, I can say that this borough here, it's not supposed to be a measure, because I know, in fact, it's categorical. Even though they called it as 1 to 5, this is a categorical value. So I can say, I want to convert this to a dimension, because 1 means Manhattan and so on. So what I can do with that as well, even more, I can actually, now that I have it as here, I can change this value, right? I can change its data type, and also I can create an alias. So if you noticed earlier, I could have done this way earlier, right? But I can say that here, I can say this is Manhattan. I'm not sure, so I have to look at the documentation. Actually, we have that open, so we can definitely look at that. If you look at the data that's shared with us, and let me see, they must have a data description here. So the borough, let me just open that up. Yeah, I know the first one is Manhattan, but I can always check that. I would assume it's there. So based on that, if I map it this way, then whenever, everywhere that I can use this borough here, and as I can put it as a label, this is where it's going to show me Manhattan. This is going to show me, let's say, Queens. This is going to show me Brooklyn. And if I'm going even more up there, that's going to show me Bronx as well. Right. So based on that, I can decide which one is which, right? So based on that, I can finish it. I finish these mapping. 4 apparently is Queens, 3 apparently is Brooklyn, and then I would assume that 2 is Bronx. So I can always use this as a sizing tool too. So 5 is, in this case, Staten Island. So I can finish these aliases. So SI. Case in Bronx. So basically I had to do, so Tableau could not fully understand what basically what this feature meant there. So I had to work slightly a little bit with that as well. Yes, Dr. Asbilin?
Thank you very much. This is very helpful. Now, these are, I assume, property values, but these were prices paid at different in different years, and we're aggregating like the property values from 2017, say, to 2022, and we know that the property prices have appreciated immensely. So, is there a way to also capture the temporal aspect of these values, property values?
So I plan to deal with that on code, but here, so in this case, we are actually summing up over total number of units for each one. So right now, the measure here is total units. So I did not get their total sale price for that, but we just got the total number of units that exist there that are sold. Let's say this can just show us how vibrant in terms of property assessment each of these areas is, right? So that's all it can do. Even in this case, we could also, if we are actually more interested in either residential units or even on commercial units, we could just as simply replace that. In this case, if we want commercial units, we could just replace that for commercial units as well. But so far, we're not looking at price or sale value. We're just basically assessments differently, right? And I do get your point. In this case, for example, we do have a sales date. With the sales date, so this is basically these values, or I like the way how Tableau deals with this. If I want to show this in terms of maps, it's not going to be something very, let's say, super helpful with respect to that, because it does not show our map over time. But what we can see, I'll show what we can do with the data as well in terms of splitting data based on different, let's say, years, quarters, or even months, because this is a composed value and it can be actually decomposed. All right. Now, so yeah, I'm going to leave this sheet as well. I can, of course, we can rename this sheet depending on what we're showing here. Basically, we're just showing total units in, I'll just name it by sheet and automatically it will apply total units, let's say valued or assessed. And I'm going to use the same, basically simple values to just show that. And even more on that, just before we move on, what I can do in this case, if you are interested in multiple, let's say, fields or that you want to do, even not necessarily with sale date, what we can do here, we could use actually other information. What I can say, for example, maybe this can also partially address Dr. Ezbilgin's question, is I can filter by year build, right? That way, maybe it can give me some idea of basically what this can do more. So let me just I can deal this as, I can actually put this as just, let me put this as a dimension, and then I can filter based on that. And I can include all of those. And with respect to that, I am able then to just filter based on that information. So in this case, I can create the filter. I'll show it here so that I have it for easy, right? For easy access. I could change the way how this looks. I can put this as continuous. If I put that as a continuous, it will be based on the range that is there. And also it makes it a lot of times very easy to deal with if we want to drag it on the sides or so. So here, if I just show this, I can basically select a year that where I want to look at. In that way, I can focus on one of those. Same thing we can do with the sale date as well. But with the sale date, we can do a lot more than just the year build, because it's a composed feature, which means it has not just, it has year, month, day, and more, let's say, important information. I can do the same thing for a sale price. I can put a filter on that. Same way, I can show here. In this case, it's just saying whether I want to add categories. If I add categories with so many different prices, so it doesn't make it very useful. What I can do here, I can just say, let's add just all for now, and then I can convert this into basically continuous value. With that, I can create the range. I can show this filter, and then I can also I'm also able to filter by price in that situation. So as you see, if I do select the high price, probably it's only going to be Manhattan. based on the values that it contains. All right, so after this, I'm gonna move forward to create a new sheet. So again, if I'm moving fast, or if you definitely have some ideas whether, you know, can I do this, or can this be applied in that situation, please feel free to reach out and ask later as well. I just, my plan was just to cover as much as possible so that, you know, I show quite some options with respect to that too. So in this case, for example, one other thing that we could look at, so I used sum of units, sum of that, and so on. So in this case, what I could do here, I could look based on, I have neighborhood information, different neighborhoods, we have, let's say, different prices, and what we can do, I can actually try and map here the average price per square feet, in this case, by borough and by neighborhood. So in this case, what I can do, I have neighborhood, but I would need to calculate information. All right, so in this case, I would have to calculate based on the gross square feet, and also on the price that's given, that's going to give us the exact average price per square feet. So in this case, what I can do here, I can create a calculated field. So if some information is not actually given to you, you can also create other fields here. And based on that, what I want to do is I just want to call this as price per square feet. Right, and in this case, I can add here a calculation, and the calculation here, they are as simple as it can get. While there can be some more, let's say, advanced coding or some more advanced calculations here, typically for these types of calculations, it should be very easy. In this case, what I want to do here, I want to say this is found by here the sale price and the gross, let's say, either in this case, I'm going to say the gross square feet that's there, and I can just apply that and say, okay, so now I have a price per square feet. So for each neighborhood, now I can say, instead of using the sum of price per square feet, I can say here, just give me the average of this price per square feet. Please sort them for me, right? And then we can find for each one of those neighborhoods what the price per square feet is. If we want to visualize it further, what I can do, I can say that, well, I want to know, I'm not sure all the time, or I want to add an additional visualization scheme to that. I want to say by borough, I want to color them by borough. So as we see here, the Jarvis, I think Javits Center in this case is in Manhattan. So that has the highest average price per square feet. And then we have Brooklyn coming up and so on. So based on those values that we have, and still I can do the same thing if I want to give an option. So the visualizing dashboards actually among the best, let's say, or the most important options is flexibility, whether you can investigate data or not. So in this case, what I can do here again, I can add this. In this case, I can add here a filter that shows here the average of this value. Again, I want to show that as a range of values. And then I just want to say, all right, let's show this, and it will show it on the side for me where I can actually filter based on what price per square feet am I interested at, right? And you as well see, we can do this actually on the whole dashboard that we will create. And again, I want to name this as average price per square feet by borough and neighborhood. Apply the same formatting as with the other. So next, I want just to, I can also, I want to go ahead and add one more just to show maybe another way of doing some of the visualizations as well. So what I want to involve here now, in this case, I want to talk about the sale date here. And I'm just going to visualize by sale. So if you notice, there's something different when I added here the sale date. None of the other features, right? So far, whatever I added as a mark there hasn't shown me what it just shows. So if I add a sale price here, and the sale price is going to be by size, you see, it just basically adding it and it says sale price, right? I can do here sum. If I want to do here sum, I'm going to have to say that, look, this is a measure sum. But now look at when I add the sale date here. If I add the sale date, that's showing me a plus sign here. What that plus sign means that I can actually go inside and expand on multiple periods of it. Or if you just, don't want to go by pressing on it, you can actually select it here. So depending whether you want to choose a quarter, a month, or even a day that you want to focus or that you want to aggregate to. So in this case, I want to choose a month here. And by default, it's showing me this view here, right? But I can go ahead and see other views as well. In this case, I can look at that by month. And so far, what I'm looking at is just the sum of the sale prices. And I have also labels here, which is the month. What I can add more, I can say, what about now on the neighborhood? In this case, neighborhood, I want that to be a label, right? So it's going to visualize that differently for me. So what I want to do this month, it doesn't have to be a label. So right now I have two labels. It's saying May, and this is Midtown Central Business District, and so on. So in this case, I want the month here just to be by color. That way, it can be easily understood that which one is actually which. So in this case, what am I looking at? I'm looking at the sum of the sale prices, in this case by neighborhood and over each month. So always, in this case, depending on the size of this graph, is going to show you some information depending on the label. This is a very, let's say, good way to try and understand patterns here. If you want to understand patterns with respect to which month and which neighborhoods actually had the highest movements or sales, and based on that, you can do it. In this case, I can scramble that around to sort as well. So either way, it can kind of show an interesting picture as well. So this sizing, basically this sorting is done in this case by the sale price, by the size of it. It's either going from the smallest to largest or from largest to smallest. And I can always say that also in this case, I can sort by month as well. In this case, see here, I want to remove the neighborhood sort. So let me sort descending here. Let me scramble that up. So in this case, for each, in this case, the month are going to be in this case, let's say a certain colored cells can show us the month, while we can always observe, and we can also zoom depending on which ones we want to, let's say, how deep do we want to visualize those.
There's a question.
Yes. So in that case, let me just say,
question.
Yeah, I can address the question. So let me just do this here. I want to order it this way, and I want to rename this so that I can use that onto our dashboard. I'm going to say just total sale by month and neighborhood. So now, can we do stack graphs to show perhaps average sale prices every 5 years, right? So in this case, we can do that, but with respect to the every 5 years, then we would have to do some work with the data as well. Because if we want to do so, let me create a new sheet here. And in this case, if I want to deal with the date, I can choose here in terms of the time that I'm going to deal with. I can always expand and keep showing them if I want to. And let me remove this just to make it more readable. And I can just select here by, let's say, quarter. So if I do this, and then if we want to get the average sale prices. Now, on the sale prices here, I would have to do some calculation. So with the sale prices, I would have to create a new feature. So what a new measure. In this measure, that means I would have to do some aggregation. So with the measures that I have so far, I don't think that we would be able to do that. But to add, let's say in this case, if we want to add a stack graph here, we could do that. If we, in this case, we have our date, we need to have a dimension and measure. So basically, let's see that I don't have, in this case, average sale prices. I can do by borrow here. And let me see that. Just move this into borrow. So for each borrow, in this case, I said quarters. Let's do maybe yearly. So I have 2 years. So I'm not sure that without doing, without creating a new field, I don't think we can show basically 5 years. So, and also the data only so far, if you look at the data as well, probably is just, I see it's just last 2 years, in this case, last 2 years. So from 2016 to 2017. But we can do stack graphs, and that only depends on the type of data you have. You can add more than one categorical value that shows, in this case, by borrow. Even within borrow, you can, each borrow has certain neighborhoods. So basically you have for one borrow, then you have for each neighborhood, and then you can have a certain value depending on what you want to show. In this case, we could show the sale price. And yeah, let's not add that. I can add it this way. That way we have by each year. In this case, we only have 2 years. And so by borrow, I can add a year if that's, if that's it. And then based on that, I can define here, like I did with the price per square feet, I can define, in this case, the, let's say, price, the average price in total. Right. So in that case, we would see something like this if it wasn't so steady. So this is by you mean what by stacked, right? Based for each of the category, you want them on top of each other. So that's we could do something like that with the data as well. All right. So I will not include this into the dashboard. So I can go ahead and create the dashboard and basically see how we can combine these graphs. So like I did so far, I said create a new sheet. If I want to create a new dashboard, this is how it's going to look. And basically, it's going to give me all the sheets that we have worked so far. And then you have total freedom in terms of how you want to rearrange those. So in this case, for example, what I want to do here, I want to add this graph first, this sheet first. And as you see, it is imported with every filter that I have. So all the filters that we used here, it can actually, they are usable. The good thing is you can always decide how big this should be. If you want a larger version of it, you can produce a larger version as well. And in that case, it will expand as per your needs. Then if we want to add, in this case, I want to add this here. I want to add that to the bottom of the graph here. Let's see, so now the good thing is, again, depending on, so the good thing about the dashboard is all of our filters, all of our information is not now particular to one sheet, is to all the dashboard, right? So in this case, if I say that I want to filter here by average price per square feet, this will affect, in this case, any of the sheets that uses that. For here, for example, if I want to filter by year, if I filter by year, it's going to affect that, well, each one as well. So in this case, if I filter, this can show it best. If I filter by Manhattan, it's going to filter Manhattan not only on the one of these, let's say, views, but in all of the views. And similar to that, I can add here also, let's say, on this side somewhere in here, I can add another view. And again, everything that I have, every other filter that I have there is imported as well. So based on what actions I take on the filters, it can help me see different type of information. And then this is basically what, the entire view here could actually be published or in a web page and still be offered where I think one example where we might have recently seen them a lot is when we did some, let's say, COVID-19 dashboards, right? Where you could filter, where you could actually put some search based on the location or so. And that's how you could see the graphs being shaped according to that. All right. Any questions? So I did try to finish that on time, although I had to skip some of my graphs. So this is the first part that I plan to cover with respect to Tableau. The other part is basically how we would deal with decision trees in Python. And if you have any questions before we move to that, feel free to tell us. So Dr. DePaulo, how should we do it? Should we have a break and then move on to decision trees, or we can?
I think we can continue. Yeah.
I have a quick question. So when we clicked on the dashboard tab, and if we do that, we will automatically see the graphs in the previous sheet.
Yeah. So if I create a new dashboard, automatically it shows me all the possible pages that I can use here, and those are all the sheets that we just created, right? So you can have basically multiple of these graphs shown onto the same dashboard.
Okay.
And you have the options, and there's more that you could do. Of course, you have the options of resizing this, moving, let's say, giving more space, giving less space, adding something else to the side of it, and so
on. Dr. Bushaj, is it possible to have this dashboard on a drive or something so I can share a link if there was interested?
Sure, I can export that. I can export that and share it on Drive after.
Yeah, maybe we'll do it after, but if you send me some, we can put it on our Google Drive and create a link.
Sure.
So if anyone wants to play with it after the workshop, they can.
All right, so I can move on to decision trees. Well, like I mentioned, connection. Like I mentioned at the beginning of the workshop, so I initially we planned to have Jupyter on the workshop. The only, let's say, reason why I wanted to showcase this in Collaborator is the easy access to it. As long as you have a Gmail account, everyone has access to Colab. So basically it's provided by Google, and it does have some good computing resources, which means you don't have, if you're just using it for quick things, you don't have to go through installing all these necessary packages in, let's say, in your computer to deal with it. So I'm going to start with an empty worksheet, but as I'm writing, I'm going to show what I'm doing as well. But due to some extent writing, I'm also going to get, let's say, some stuff that I've already prepared and just go over those and what those will cover for us. So I'm going to create a new notebook here. All right, I just want to name this properly. And the first thing that I want to do here, I want to get our data here, since this is basically on cloud, we don't have the data there. If you're connected to your Drive, you can access that directly from Drive. But if not, if not, you can just drag and drop. So here, basically, I'm going to drag and drop our data. And Colab is free to use for everyone with a Google account, and you don't need any installing, any downloading, or anything. Just you can go to the colab.research.google.com, and then you can get full access to it. So what I'm going to do here, I'm just going to paste our data. So the reason why I have to drag and drop our data here is because I did not connect it to Drive. And also, if you just are using it in a session, as soon as the session expires, you're going to have to do that with your data. So in this case, it will just take a moment to get all the data. In the meantime, I can talk about the libraries that we need. So when we're dealing with code, I try to simplify on basically in terms of what we need to know and what's useful for a certain topic. So in this case, I filtered some information based on the topic, and some of them is more general and crucial to the part of Python. So I'm gonna paste my libraries that I plan to use today. And all of these libraries are most of them are very typically used, like pandas. These are for visualization, NPs, NumPy for calculations. Scalearn is basically every type of model that we can apply. You're able to find it there, which we'll find for 3 as well. And then I have just some quick functions that can help me visualize, or let's say calculate some information fast. Now, if you notice, in some cases, I do say this line, or let's say if not the IP. So basically this means that just install it if it's not installed already there. And in this case, if I run this is going to install all the things that I need through this, basically through the workshop. And the good thing, or why I like Colab, especially even with my students, when teaching an audience who is not very, into coding or so, because it's very simple to use. In this case, we just got the libraries. Now I can just start another line of code that can help me here. Now, if I have the libraries, I can go ahead and read this file. If I know the path to that file, I can just say, this is my New York City data frame. And in this case, I'm going to say pandas. So read. And I already copied the location of it, so it's just going to read this file for me, right? And now, now we know, I believe we know a little bit more about the data because we just visualized it. So if I just show this data here, it's basically all these columns that we saw in terms of the dimensions and the values and measures that we saw. And we have 84,000 and something rows, and then 22 columns for each one of those. Now, this is extends data, even though, and I shortened this just so that this is not very, very difficult to compute, but still it's quite a lot to deal with when it comes to decision tree. So what I can go ahead, I can move forward, I can say here, if you want to, there are many ways how we can look more into the data. Typically, what I do when I start reading some new data, I just want to see what type of information I have there. Do I have any null values? Do I have any work to do with, let's say, to fix on that? For example, one quick thing is I can say that in this case, what I want to do with this, I want to check if I have null values for any of these, basically for any of these columns that I have. So in this case, it's going to show me 0, right? Now, it tells me that I don't have missing data, and for none of those, that's always very, very suspicious. If you get good results, be suspicious, something's not correct, right? And with this, with the current shape that we have, it looks, very, very not real. So what the problem can be here is, if we look at the information of the data that we're trying to deal with, you can see that if I say here, so for the New York City data frame, I want to see here some information. If I see this information, it's basically going to show me that just some of them are objects, right? So this says it's an object. What that means in terms of Python is that it's just the most general expression of that, right? It's like you have some type of species here, and you're just saying, oh, this is species, right? Human can be species, a lot of things can be species. So in this case, saying object, that's just generalizing it. So that means, in this case, anything can be taken as an input. Even if we have a space, it can be shown as, oh, there's no missing data in this point. So what we need to do there, if you want to deal with that, actually, we would have to convert them to the proper situation, proper, let's say, meaningful values. In this case, boroughs, I have integers, right? But neighborhoods are categories, they are strings. I could convert them to string, basically to text, and so on. And we'll do some of that. So next, what I can do here is basically, so I'll go into decision trees, but again, this is, let's say, when we're dealing with these types of situations, or when you're doing this over code, most of the time you're going to spend a significant amount of time just trying to make sure that your data is, let's say, reasonable and you don't have any problems with it. So in this case, I can check if I have duplicates as well. I can just say, let's see here. So in this case, I can just get the sum of all the duplicates that I have in this. So in my New York City data frame, I can say duplicated. And then I can, based on that, I can say, so with here, it will just show me if I have any duplicates on my data or not. And it seems that through all of that, I don't have any duplicated data. So that works very well. I can move forward with that, just simple checks. And later on, so with respect to the info, so it showed me here that I have no missing data. Now I can show that in this case, I can prove that actually we do have missing data. So in this case, what I want to do before we move there, I just want to say, let me see if I convert one of these data types into its proper form, and then we can see if we have data. And the most important that is basically our sale price. So this is, I can just say for sale price, in this case, our sale price here is listed as an object. So it should not be an object. This is actually just a value, a numerical value, right? It has to be a numerical value. So in this case, I want to say convert this to numeric value. And so NYCDF, basically, this is going to be named exactly the same. I don't want to change anything on that. And if there's any errors, I want to just force them. Data frame. So in this case, if I do this, and if I run again, just to see here if I have any missing values, now basically this is not treated as an object anymore. In this case, this is treated exactly as a numerical value. So that means I have now 14,561 missing values here. Why? Because when they treat it as objects, even a space can be an object, but a space cannot be considered a number. So we consider or any other type of input. So in this case, you see I have now multiple missing values. So this is a very common issue with the data, which means, and why this is so crucial is whatever analysis that you want to do further, if actually you're not going to make sure that your data is correct, it's not going to work in any of those, right? So that's why this process is critical. So in order to make this easier, what I've done, I'm just going to use some selected features. So how I do that, I can just say that in all of this data frame, I want to use borough, zip code, total units that I have, land square feet, gross square feet, and then of course sale date and sale price. So now if I run this, let's see here. All right, let me rename all of those fields just for a moment here. I want to rename, I don't like spaces. The spaces in between these are problematic, so I want to rename those spaces just so that I have it very easy to deal with these values. So instead of having a zip code with a space on it, I want to always have that with an underscore. So now basically what just happened, I just made this a little bit easier by selecting just some of these columns. So we had 22 columns. Now we went from 22 columns to 9 columns. And I'm going to use just those to basically try to visualize some trees and try to go over possible problems that we have. Now, the same thing that happened to the sale price here. Same thing that happened to our sale price in this case, it can happen to other columns as well. And basically, how do we identify that? By making sense of the data. In this case, the building class category is an object. It should be a category. Building class at the time of sale is an object. It should be a category. And we can always deal with that and try to basically isolate those issues. So what can I do here for building class? Same way that I converted that to a data frame, basically to a numerical value, I can just say I want to convert this in this case to a category. So I can just say this has to be a category. And then I can basically fix that. And again, the same thing's going to happen. If now I have any issues there, all right, I already ran this line, so it should be fine. So if there's going to be any missing values that's not anymore fitting on the category, if you run this line again, it will definitely show you that. So basically dealing with these missing values, you're going to have to try and do that earlier on. So if we have missing values, we can always try and isolate that. We could see these missing values for each one of the fields that we have. And if you don't want to isolate these values, that means you're going to have to deal with some of this information at hand. So why can this come up as object? It's just basically on the way how data is stored into the CSV file. So basically, whoever provides the data, they can take care of that. So what I want to do here before, in this case, I want to make sure that everything that we're dealing with is actually on the correct format. To do that, I'm not just going to, let's say, convert just one or two. I want to convert all of these values that can be issues for us in terms of the data that we have. So what can I do for that? I can go ahead and avoid any other issues that we have, and I can just show that with this, we have quite some missing values here. Just avoid that. So I'll do this line ahead just to avoid any issues. Should be able to do about those. So basically, if I run this, we're going to see that for 3 of those, we have issues. We have quite some missing values from the land square feet, gross square feet, and then we have sale price missing values. For the others, it doesn't seem to have any problem. We can go ahead and select those. I'll remove this empty cell. We can go ahead and select those features. And now we have this data frame, which has less fields in this case, less columns, but again, we have some missing values. So how can we deal with that? We can actually, let's say, visualize a lot of time visualizing missing data is let's say, very helpful. And how would we do that? In this case, I can perform a calculation. So here I can get the sum of the missing values, divide them by the length, and I can get the percentage of the missing values for each one of them. So in this case, sale 17%, 31%, 32% are missing from each one of these data, right? And furthermore, actually, we can put them into a data frame, and then based on that, I can also visualize them. So we can actually create a data frame out of this. Basically, it's data frame. It's the same as saying we can create a table, and then we can plot all of this information and show that in terms of a graph in our case. Okay, sometimes the Colab is not very good at showing graphs. So what I would try and do is just print them out into a PNG format. But yeah. So you can always observe them there as well. So in this case, when we have missing values, it depends on the situation that you want to deal with. If you are able to say that, all right, this is a huge part of the data and it would actually impute my analysis, and I want to have some information on that, what you could do is you could try and use different ways. In this case, you could either use a mean, median, or any other relation of the data to fill out the information. But be aware, if in this case we have 30-something% of the data, if we try to use a mean, we're actually going to force a center on the data, which means we have the power to modify a lot of our data. So in this case, we can drop them, we can try to modify them. I can show them both, right? If we were to just select a mean, we would just say, fill out all the empty data here. So fill the not applicable data here just with the mean of that column, or easier also we can just say just drop those values as well. If I say just drop, that means now our data frame, if I check the shape of that, is going to change. In this case, we had 80-something thousand records, so it just fell down to 48 because I deleted, I basically ignored all of these missing values. Now, a lot of times, as I mentioned, this is very helpful to try and, it's a crossroad basically, depending on how you want to deal with and how it makes sense to deal with missing data. You can go ahead and try to do that. So to come closer to our point here, we could always do some more analysis in terms of numerical values, in terms of categorical values. We could deal with each one of those, how we can, let's say, deal with skewness of the data, how we can deal with distributions of the data, and so on. But just to basically move us to the point and closer to our main topic, what I want to do, I want to have, in this case, I basically want to look at two different types of situations. Common situations that arise with decision trees is whether we want to do regression or classification. It just means that whether we want to deal with a numerical value or with a categorical value. If you want to deal with a categorical value, that means in this case you're doing classification. So basically, here this is what I want to do in this case. So I want to create a copy of this data frame just so that I can differentiate. I want to show both of the worlds basically. I want to show how we can predict the sale price. In this case, is a numerical value, or how we can predict that as a bin. As you've seen a lot of times when we do, even when Zillow or any other, let's say, assessment page does some sort of assessments, they will give you a range. It's just because, again, we know that with continuous variables, it's very difficult to predict on point, and you're going to have issues with that, and you're going to have quite some errors with it. But again, when we try to let's say classify in categories, we can split these prices in categories, and we can actually kind of see or try to classify where a property will fit in this case. So I just want to create a new data frame as well. So I'm going to say new New York City data frame for category, and I'm just going to say that this is actually a copy of the other data frame that I had. So now I have two of these data frames. The first thing that I'll do, I'll just go ahead and in this case, I want to deal with here. In this case, a numerical value or a continuous variable. And with that, so I'm going to use some of the typical code we do. In this case, what I'm going to do here to make sense, I'm going to convert the categorical parameters in terms of different, let's say, features. And then I'm going to split my data. The first split that we do when we try to deal with predictions or classification, as you know, is we have a label. In this case, we have a label, which means we have our sale price, and we want to keep that hidden. What we are doing, I'm just saying that here split, this is the sale price. It's completely one other, let's say, parameter, and this is everything else, basically my predictors, and this is the value that I want to predict. And then we're using a train test split, which means I want to have 4 groups of data. I want to have data that I use to train predictors, and then I want to use the label for those data. I want to have data that I use to validate or to test, basically, and then I want to have the label for that. So all of these groups show me that. So the analogy used typically when we do this is we want to see, for whatever model we're building, we want to see whether it makes sense, whether whatever we get actually is a notion of the truth or not. So always we have data that are not shown to the models, and then we tell them to predict them. And that only works if we have labels for that, if we know exactly how good or how true or false those predictions are, or how far from the truth those predictions are. So in this case, I have a training set here, which has around 29,000, and this one has the validation set has 20,000. Where did we decide that? I said that this is the test size, 40% of the, let's say, data. Typically, how I would do it in most of the situations, especially if I want to test multiple models, I actually split out in 3. I have a training, a validation, and then I have a completely hidden test set, which means I will test all the models with that and see how they would perform. In this case, we can keep it simple to just 2 types of sets. And the same thing, we could look inside, let's say, for the validation sets as well, for the shape of both. If you look at the shape, just basically, if you look at what X, if this makes it easier, if you look at what X is basically every column except the sale price here. Every column except the sale price. And if you look at Y, is basically our sale price only. So we have split our sale price. And if we look at any other, let's say, any other X here, are those predictors, any other Y is actually just the value of the sale price. Now, how would we build a tree? So in this case, if you I did not focus a lot on that at the beginning. I just mentioned scale learn, but from the scale learn.tree, I have imported the decision tree classifier and regressor. Decision tree regressor is used when you want to use decision trees on continuous variables, and the classifier is when we want to use that on categorical variables. So in this case, how we can do, basically how we can build a decision tree classify, in this case, regressor. I'll use the decision tree regressor to just get a view of that. So what I want to show here is just an initial view of the tree. So what I'm doing here, I'm just saying build a regressor. Random state is just basically so that this result is reproducible. And then I'm adding this parameter. Now, if I don't add this parameter with the data set that I have, we're going to be stuck here for a while waiting for a result. Because just because this data is very, very huge, I'm just setting a limit saying that just go a maximum of depth of 5 in terms of the relationships here. So for time purpose, we can do that, and we only have, let's say, 27 nodes. So what is this going to do? Basically, it's going to just, let me make this maybe wider here. It's just going to build the tree depending on the information that we have on the set. So in theory, what this does is basically it looks through all the columns that I have as predictors. It tries to identify what the best rule is. And as we know with decision trees, is basically checks saying that if gross square feet is less than 100, so 1,473,000, and so then if that is true, then check another condition. If that is false, then this is what the value is set. So as simple as that. And then depending on that, we can build conditions. If, let's say, this first condition, let me make that larger just so that we can see. If this condition is true, then if this one is true, and so on, based on that, we can end up with a value that's being predicted. Now, this predicted value, when we're dealing with continuous variable, is just the average of all the observations that fulfill this long condition. In this case, there are 347 records that fulfill all of these conditions, meaning that the gross square feet is less than or equal to this value, zip code is less than or equal to this value, and so on. So that will we build these decision trees where at the end of those we have nodes. As you see, a lot of them are predicted, let's say, close by in some certain values because they are just the averages of the records that abide to a certain rule. Now, in this case here, the tree that we built was totally limited from us on how just basically we wanted the maximum depth of 5. Now, this is not going to give us the best result. We call this as parameter tuning, and we want to be able to find the best tree for our data. That's what we look for when we want to use, let's say, that for decision making. Now, before we just even look on that, we can actually observe the importance of these factors. One question might be, why did we decide to split here on the top of it? Why is the root as gross square feet? Right. So in this case, using the decision trees here on the back end, just use a Gini index formula to calculate which one is the most determining factor on the columns that we have, and that happens to be in this case the gross square feet. And if we want to investigate the importance of each of these columns, in this case we can look at all the columns and we can get the importance values based on this tree. Now again, I want to stress that the tree that we created is just basically our tailored tree. We did not have any let's say finding the best tree so far. So what we can do, we can just produce a graph where we can actually find out what the best, let's say, what's the most important parameters are in this decision tree. And once we have this model, we can do the simplest thing of just basically predicting here. In this case, what we're doing, we're predicting the training set, which should show us basically how we did on training, which the model has already seen, and we're predicting the validation set, which the model has not actually seen. And for each one of them, we can get some sort of statistics. Of course, the mean errors would be reduced. Some of it, or let's say RMSE is typically used to check how are we doing in terms of continuous variable prediction. Meanwhile, this is what the validation said. As you see, we have quite some more errors. Now, these errors look super huge. Well, that has to do with the range of the data that we're dealing with. A lot of times when you're dealing with a long range, using these methods to try and isolate to a certain number, it's always going to produce a high error, right? But if we were to convert this into a percentage, or how far we are, in fact, in the whole range of the values that we have, it's always going to try it. That's a good, let's say, way to try and decide how bad this model is doing. Let's say, even in this case, if I ask you to say, predict a number from 1 to 10, right? Whatever error you're going to make from predicting that number, it's not going to be, unless you want to mess, right? It's not going to be longer than the range. But if I tell you to predict a number from 1 to 1,000,000, right, you could be making a way bigger mistake. The same thing happens in these situations. Now, the biggest issue we have with these trees is overfitting, right? So in this case, what we do here is we try to find the best tree that does not overfit. So how do we do that? We use what we call a grid search. Basically, we define many parameters here. I'll share the procedure here. We define many parameters, basically a grid of parameters, and then we want the model to try them all with our data. And then we can find out the best tree that we can with respect to our data. Now, this can be time consuming, especially if you are providing many different, let's say, many different values to do that, right? So in this case, for example, what I'm doing here, I'm saying that look first in between these values. So max depth can be 5, 10, 15. And I'm limiting, right? Because just I want this to be timely done. And then you can look by different impurity degrees, meaning that just depending on how pure a node, how pure a decision is. By decision pureness, we mean that having conditions such as saying all the, let's say, properties that are less than $2 million, and we can split in one branch there, and all of them are sold around this certain price, and we average on that, and we assume that's the price. But in this case, we have a lot of options that we can use to tune this. So basically, this procedure, like grid search, we can call it as tuning. So finding the best decision tree for our data. Why is this so important? Is because this is one of the weak spots of the decision trees. It totally changes with data. If you just have now if I try to shape this data set differently, meaning if I now scramble these training and testing sets and validation sets, it's going to produce totally new tree. So this is actually, let's say, a weak spot for the regression and also classification trees. So in this case, I've shortened it enough to be, let's say, prompt. So we're going to have to wait for, let's say, a decision there. We can, in the meantime, it's processing. We can move on to look at other, let's say, to look at our classification trees as well. So basically, and this is a small run. In this case, again, Google Colab does not overwork the computer or so. It's just basically using the resources that they've assigned to you to just perform these computations. So that's one other benefit of using the Google Colab as well. So far it has found the initial parameters for our first initial tree, and then it's going to find the best improved parameters with respect to that. So what this does in the back is just uses cross-validation, which means it creates sets, it tries to find out the best, let's say, rules, and then creates totally a new set, and it tries to find the best rule as well. In that way, it discovers the best tree, actually. So once we do that, what I want to do just after that, I want to be able to just get the error report and the prediction accuracy for each one of them. Now, if we compare the result that we will get on this cell, it will be slightly improved over the previous result that we got here. Just because instead of just using a random tree like we did here, with just a naive decision of saying don't go over this depth, we are actually computing it, or we are putting more resources to compute here the best possible tree that we have. Sorry if I missed any of the questions. It's just at the back, at the end of my screen there. And
have you used the date as an object or date?
in fact,
We haven't done any change on date, right?
that's actually a very good question. So I select the sale date. I would want to actually change that. So it's a very good question. In this case, the date is like a timestamp, and we can.
But
So
since you made get dummies, you use it is not necessary anymore, right?
Yeah, I think actually you're right in that. So the problem here is what I want to do with the date is try to detect cycles. So instead of just using that as a timestamp, I can just create a new column with the, let's say, sale month and try to see that, or even sale year and try to see that. So basically, even before I do this, I can just say around here, I can put a new cell doing that. So in this case, I can say the New York City
can improve maybe the accuracy score or score, I mean.
Yeah. So you mean the accuracy score for the regression?
Not accuracy. Yeah, but this is not classification, regression. So
yeah, exactly. So we'll do with the classification as well.
Yeah.
So what? And thank you very much for bringing this up. This is actually a very good point. So in this case, I can show in this case what I can do here. I can convert this to a date time if it was just as an object. So I can say basically to date time here. And in this case, if I do that, then I'm able to extract information. I can just extract the month and I can use that as a categorical value, right? So same as we would do in a time series. So with respect to that, I can say, all right, what I want to get here is New York City here and sale date. Once I have this, then I can actually say New York City DF and I can create a new here sale month. And that is just actually an extraction from the New York City data frame here for the sale date. And I can just say date.month. So this will create a sale month, and then I can drop the sale date completely. I don't really actually need that. So I can just say right after this, I can also say New York City DF, and I can say drop this in this case, the sale date, because I just, let's say, made it more useful. Yeah, thank you for bringing this up.
Thank you.
This is actually very, very important. So let me see if so this is generated basically with our best 3 here. So this is what we would get in terms of our best 3. And actually, if we investigate, yeah, see, that's a very good catch here. Basically, our sale date was not very useful with respect to having it as a timestamp. So in this case, the good thing with the models that we build like this is that actually we can just modify our framework, in this case, sale date is that, okay, save that just a second. Go ahead. Let me do this. It might be slightly better to just see if we have a processing issue. So I'll just try to rerun this here. I don't see any very visible issues with the naming that I use. I think I used the sale date correctly. So let's see if that's. Here, so we have we have dropped this, we have a sale month. So basically now I have some categorical values that I can use to predict there. So our sale price here.
I think we have to add sale month into the features we have selected and drop the other date.
Yeah.
There was a list of features we have selected. Yeah.
No, that should be added as I added after, so it should be there. See here. If you look at the New York City here, I just say this. Right. And so in this case, I can say I can actually modify this directly without dropping. Or about the confusion. I try to prepare so that we don't have to do things on while we work with it, but yeah, so now we can go ahead and basically in this case I can copy this. I can get dummies with that. So we're gonna have quite some more columns just because we have 12 more or 11 more, considering that for each one of those. So we now have, again, It's interesting in this case, gross square feet still looks the most among the most important features that we have. In this case, the matplotlib. So I've seen that the biggest issue that happens with Colab is that the matplotlib inline. So basically the visualization will fail sometimes. And if you re-import the library, it will just bring it up again. And yeah, so we have the accuracy. I don't want, so I want to run this. I'm going to run this with a smaller amount of parameters just for the sake of building this faster. So we don't have to basically wait on that. So I'm just going to reduce the parameters. I can share this later with the, let's say, amount of parameters that I used, or even if necessary with even more, just so that this runs faster and it's more basically we can move forward to the main point. Yeah, so this date change actually I think has made this way more meaningful and stronger in terms of also trying to involve the cycles in terms of if we have an idea whether there are monthly cycles on that. So that should be some crucial information. So now this is the generated tree. So if you look at the generated tree here, again, in this case, we have the grass sale, the grass square feet as the most important one. I want to just point maybe and see whether we have date as a factor there. So we don't really have the data as a factor. And if we compare this to the previous, so this is the, yeah, it's a simpler, basically it's a simpler tree because we just used a lot less parameters to generate it. So it's not going to be as good as a solution. But if we look even, let's investigate here. If you look at also the RMSE or the mean absolute error with respect to comparing with the previous one, that should definitely give us a smaller error just because we found a slightly better tree, even though we involved not many of these parameters in there. Now, if I let that grow a lot more, this tree is going to grow a lot more. But again, that's basically depending on how we can define or how let's say, how deep we want to look for the best features that describe our data. Now, the second part of that, I want to deal here with the let's say, in this case, classifying. So it's not, there's not much difference. So I can, there's not much different with respect to the way how we would actually, let's say, coding perspective or to the way how we would deal with that. But a simple common strategy that we use here, we use bins. Now, there are many ways how we can create bins, right? Typically, it just depends on the data distribution. So one other thing that I would do, let's say more if I had time to go through the workshop, is we would, let's say I would look if there are outliers. So outliers are not very helpful with respect to securing a good prediction or classification. I could remove those outliers. I could remove skewness from the data if that's necessary, because what can happen is that, you know, you have a huge amount of data that's focused on one particular range while the other is way out of range. So in this case, since there are many different ways how we can do it, what I went with, I just used in this case, just created 20 bins based on the parameters that we have. So I used our sale price to create 20 bins, and I added that bin price onto the New York City data frame, or on the categorical data frame that we have. Basically, we already copied this. If we copy that with the, all right, we can do that again so that we have the newly added as well. So basically what we've created here is now a bin price. In this case, this bin price will show a category, meaning it will show for each price that we have, it would actually point to 0, 1. In this case, it's 0 to 19 because I just said 20 categories. So how did we pick that up? For the purpose of this one, I just used, let's say, a certain amount of categories. When you're dealing in reality, you would check the distribution that that parameter that the sale price has, and then move forward with a certain decision. Same way that we dealt with the regression trees, there are similarities a lot in the way how we're dealing. The only difference that we deal with here is how do we vote, right? So basically, based on the rules, what happens is on the regression trees, we build certain rules, and for all the elements that are part of a certain rule, we aggregate. Basically, we get the average, and that actually happens to be our prediction. But for the classification trees, for each split on the tree that we have, for each condition added onto our basically decision, then we vote based on belongingness, right? So, for example, in this case, if we build this tree, we're going to have some node points saying that if these conditions are met, this record, then it will belong to this group, to this category. So let me show that as well. So again, I don't want to, I believe I've made a point that, you know, we can search for the best tree, and that can actually, you know, it can be easy to just let it run, or even if you have more resources on your machines, then you can use more resources. Same as you could actually get or purchase more from the Colab as well. I want to reduce the number of the searching for the best classification tree just for the sake of having this, you know, easier to deal with, and so that we don't have to wait for a certain result. As in this case, again, what I'm going to do, I'm trying to find some initial parameters. Then I can use a second procedure to look deeper into those initial parameters. And then I can build the best classification tree. And I get the importance for each of these features that I have. So again, once I get that, now there's a difference. So I can investigate the importance parameters. With those, I can, easiest way I think it would be to plot them. You can plot them side by side, and we can see which one actually, or let's say whether we have some differences, whether we want to categorize them in bins, or whether we want to predict them and at the point price and continuous variable. So here, what I'll do is I'm just getting those basically here the importance of each of the fields that I'm using. And then based on that, in this case, gross square feet came out. So again, if we were to look deeper in terms of these values, we would definitely achieve a way more, let's say, split result in terms of the parameters that are more important to that. So if we were to, I want to visualize this. So this is our tree that we built, the opt classification, so optimal classification tree. So if I want to build that, again, due to the simple rules that we have set, or simple parameters, is going to show us a very simple node, right? So in this case, saying that because the most important thing is the gross square feet, if this is less than that, then it's going to classify them as basically part of a certain group. And if this is else, it's going to actually classify them as a part of another group. So if we were to run in this case, I want to put this running just so that while we have a discussion, this also can finish, just so that we have the full tree built in this case as well. So yeah, the one main difference that I'll show about that as well is when we are doing predictions, again, we're checking the squared or root mean squared error or mean error that we have on the predictions. But when we're dealing with classifications, we're basically dealing with group belongings. So in that case, we're going to show a confusion matrix and accuracy for that, which means we want to see how many of these we have let's say classified correctly, and where we did our mistakes as well. So with respect to that, we'll show a confusion matrix as well. I'll just prepare that, and I'll just add, once we have this decision tree built here, we can just investigate it. classification, or let's say the confusion matrix as well. Meantime, if there's any questions or suggestions, we can definitely deal with it.
Does the decision tree make excuse me. Decision tree makes the feature importance order in terms of the information gains? Or?
Yes, in terms of what the decision tree uses, typically you can and you can actually change that. There, among the most used measures to split decisions is actually either Gini index or the entropy. So if you use, you can specify that where you can specify that as a parameter on the classifier itself, which means based on the decisions that you have, based on the parameters that you have, it's going to make up the best, let's say, the best tree. So with respect to that, for example, what are the, let's say, the conditions you have, or it can be a minimum impurity decrease, it can be certain sample split. So for example, this means that you want to have enough proof that a rule exists there. So you want to say that I don't want to consider a rule where I only have one proof of that. Instead, I want a minimum sample split of 100, which means I want 100 observations as a proof of a certain rule. And that makes the tree a lot more, you know, work a lot more so that it stops early, because it doesn't have to investigate into details. That's why these parameters play a huge role in terms of tuning and putting the tree in the, let's say, finding a good accuracy with respect to that. So in this case, again, maximum depth, the best so far seems to be 1, and then we have a minimum sample split as well. So we will have sort of, I would say, a very simple tree as well. And in this case, if we investigate this, this is how it looks with respect to that. We have on the training set, we have an accuracy of 99.92, and in this case, on the validation set, we have. So what could be the issue here? In this case, if you notice, the confusion matrix is not well represented. So here, it's very easy for the decision tree to make rules because it can classify as 0 for most of the elements that we have. So part from this is because, let's say, I skipped in terms of winning time, I skipped on dealing with skewed data, meaning a lot, when we built 20 bins, let's say, a lot of the categories, a lot of the values fall on the first bins because we have built these equidistant bins. And that's why about 28,000 values here fall as category 0, meaning category 0, it would be from, let's say, a certain value to a certain $1 million. And we could always, basically, we could always compare the feature importance in this case with respect to the to both of the plots that we have, to the in this case for the classification model, only this one came as important. With respect to the regression model, let's say we had multiple features becoming more important, right? So just to basically recap, and I want to mention that there are many other libraries that can allow us to deal with decision trees, right? Let's say, I would say good mentions would be the D3Wiz. In this case, it can help build, like, let's say, if this is not very visually satisfying, that can build even better trees with respect to that. But again, it would need more customization. It would need you more to deal with that. And with respect to the case in point here, whenever dealing with some sort of let's say prediction problem or classification problem, this is a very simple trick used if you want to bin those. The good choice, it would depend on your purpose. If, let's say, you want to find an initial price or some sort of estimation, then a regression tree can be a very good practice. But if you want to just determine basically where a cutoff happens between the value of a property, then it might, let's say, the classification trees can develop some good rules so that you can define where the property can fall at. So I hope this was helpful. So it's one of the things that I have a difficulty with is saying, in this case, I'm not sure how technical we should go, because I wanted to keep this as general as possible so that it can apply at different fields. I can share this. I can share the data set as well. Let's say also the revised data set, so that we make things run within certain seconds. But again, even if you're dealing with other data, please, you can follow the same procedure. You can see how that looks, and if you have any questions or so, I would be more than happy to answer any questions you might have for that. Yes, Dr. Topaloglu.
Thank you. Thank you for a very well prepared workshop and presentation. This was a good refresher for us, especially for some of us who's been busy with doing some other things. I think we are about our time. If there are no other questions or comments, I think we can wrap it up.
Yeah, I was forced, so I wanted to stay on time, so that's why
It was pretty good, yeah.
I kind of negotiated with some of the stuff that I had.
Not professorial, if you ask me. Professors usually go over time. I appreciate that.
Well, we do that with students, so it's enough.
All right. Thank you everyone for participating. I will post this on our YouTube page, and I'll share the link with you. Yeah, and if you can send me some of the materials that we discussed, I'll put them on our drive and then share the link as well.
I'll actually, so I'll add some comments on the stuff that I think that would also make this even better if you want to try your own data too. So I'll add that with the additions that I want to, add there. So that way, hopefully, you can just test your data and see if that's all right and if it helps.
All right, sounds good. Again, thank you so much. We appreciate it, and we'll see everyone in other events. As you all know, we have a conference in October. We expect all of you there. Please submit your research papers. The submission deadline is at the end of July, and the conference will be in our campus at FLA Dickinson University. So you'll pay a nice visit to New Jersey, and we'll show you guys around. We'll listen to some nice presentations. More details can be found on our website, snasscholars.org. I appreciate the participation. I'll see you all in some other events.
Thank you very much.